You thought we were done, but we have 4 more quantum realities coming up for you. The very first is a favorite of the superhero movie genre, the multiverse interpretation. You may have seen this in Ant-Man, The Avengers, and numerous other blockbuster films. This is perhaps the most overhyped and misunderstood interpretation of quantum mechanics. It's called the Hugh Everett many worlds interpretation, which posits that every possibility of the quantum wave function actually occurs in some parallel universe. And this means that at every moment, the multiverse splits off into an infinite or near infinite number of new alternative universes. And you might notice something about this interpretation. It doesn't make any freaking sense. The multiverse interpretation is absolutely absurd and outrageous and nonsensical. Instead of trying to answer the problem of the quantum wave function collapse, it just says it doesn't collapse. Everything that can exist according to this interpretation does exist. So there's no actuality, there's only potency, and everything that is potentially possible exists in some number of parallel universe. Somewhere there's a universe just like this, but it all of a sudden, and after 1 second, it spontaneously transforms into a universe consisting entirely of car dealership inflatable, like those big like tubey things. And this is, according to many worlds, equally likely to happen in our universe as the universe proceeds according to the set of natural laws to which it is conditioned. It is always conspicuously seems to evolve along a structured trajectory. So we'll wait 1 second and see what happens. Okay, so in our universe, there is structure and order and law, whereas in the multiverse, all outcomes actually occur. And the multiverse interpretation basically applies a principle of indifference, which means that because there's no positive reason, according to this interpretation, for assigning different probabilities to competing statistical or predictive assertions, equal probabilities must be assigned to all. But wait a second, isn't that exactly what the wave function was all about? Is assigning different probability amplitudes to different potential futures? So if the universe just has this multiverse wherein everything that can exist does exist, why do we even need the quantum wave function? And is there any evidence for the view that it doesn't collapse but actually expands into a space of new parallel universes? So therefore, the multiverse adds precisely nothing to our understanding of causality or quantum mechanics. Instead, it sidesteps the issue entirely and makes the baseless assertion that there exists an infinity of other universes parallel to our own. Perhaps the multiverse interpretation is suitable for the Marvel Cinematic Universe, which, according to the multiverse, has an equal degree of reality to our own universe, so how dare you not believe in Ant-Man and Loki. But still, a constantly branching tree of parallel universe can be tentatively rejected in our own universe because of Occam's razor, which is a scientific and philosophical rule that says that entities should not be multiplied unnecessarily, and that we should prefer a theory with the fewest assumptions. So, where the multiverse is literally defined as multiplying unnecessarily the number of universes, we could even go as far as to say that the multiverse theory is illogical, or at least improbable and unfalsifiable, meaning that no observation could disprove the theory. Thus, I don't consider the multiverse interpretation to be scientific at all, but rather an instance of misguided metaphysical speculation masquerading as science. As Bryce DeWitt, one of the greatest physicists of the 20th century, said, the idea of 10 to the 100th plus slightly imperfect copies of oneself, all constantly splitting into further copies, which ultimately become unrecognizable, it is not easy to recognize and reconcile with common sense. Indeed, it is not. However, despite its seeming absurdity, it is supported by 18% of those who study quantum mechanics, making it the third most popular quantum mechanical interpretation behind Copenhagen and information theoretical approaches. Number 5 is the quantum logic interpretation, which says that the world obeys a non-human kind of reasoning. This is perhaps the most reasonable and humble approach to understanding the collapse of the quantum wave function, although I do not believe that it is ultimately correct. Quantum logic posits that the wave function collapse is real, but is caused by some hidden variable that is unbeknownst or perhaps unknowable to human theorists, and therefore outside the domain of science. The problem with the other interpretations of quantum physics, according to quantum logic, is that they assume that quantum systems obey human logic of potency and act and form and instance. But since all such efforts to understand quantum mechanics through these methods of theorization has failed, quantum logic theorists posit that quantum systems do in fact obey some sort of logic and order, but it's not necessarily within the limits of our knowledge to find out what this order is or how it comes about. Quantum logic is basically giving up on quantum mechanics interpretations, but that's not the worst thing ever. It says that quantum systems obey what's called a crazy logic, which, although it sounds like a really judgmental phrase, it just means a logic that can't be understood within human categories. The sixth quantum reality is called neo-realism, which says that the world is just made of ordinary objects. Basically, that's what we believed before quantum mechanics, and they're not convinced, these neo-realists. And this is the most simple and, dare I say, naive interpretation of quantum mechanics, which denies the quantum wave function collapse and does not even bother to substitute in a conceptual substitute, no matter how absurd it may be, like the multiverse. It doesn't even try. It maintains a baseless faith in the world of ordinary objects, independent of perception or ultimate reality. The world is populated in this theory by objective entities, and there's nothing more to the story than that. An observation has no effect on their properties. This is the view most famously taken by Albert Einstein, who believed in the principle of realism, which states that physical objects exist independently of our perception or measurement of them. Einstein famously disagreed with Niels Bohr, saying that surely the moon existed even when we were not looking at it. This classic reductio ad absurdum, which you'll recognize from our course on logical reasoning, demonstrates Einstein's common sense argument against Bohr's anti-realism. We all have the intuition, the deep-seated feeling that real objects exist separate from observation. But is this intuition enough? I personally believe no. I believe that the findings of quantum mechanics, in particular wave-particle duality, demand a radical revision of our assumptions about the physical world and what it even means to be a quote-unquote ordinary object. For instance, objects in the quantum world travel faster than light. Hence, in principle, in favor of taking a realistic position, the neo-realist has to accept claims of the existence of time travel, reverse causality, and more to make his claims work. He's still at odds with the view of reality in classical mechanics and relativity. So therefore, it's not clear whether the neo-realism claim that the world is made out of ordinary objects is consistent with a quantum mechanical view of the world. In my opinion, it is not. However, the intuition that an objective world exists independent of measurement was enough to convince many of the greatest physicists of the 20th century, including heavyweights such as Einstein, Max Planck, Erwin Schrödinger, and Louis de Broglie, all of whom we will discuss in this course. Quantum reality number 7, our final and one of my favorites personally, is the consciousness interpretation, which says that consciousness creates reality. The consciousness interpretation is a subset of observer-created reality. And it is basically valid for the same reasons that observer-created reality is as well. It in principle allows anything to register a quantum system through a generalized observation of the universe itself, whereas the consciousness interpretation, as opposed to observer-created reality, says that only beings endowed with consciousness, such as you and I, are privileged to create reality. Perhaps its most famous proponent, the genius and polymath John von Neumann, argued that if quantum theory is correct, the world cannot be made of ordinary objects. Therefore, the neo-realist interpretation is logically impossible. He suggested that objects are given by the observer's consciousness, suggesting an agentive role for sentient beings in creating reality and determining quantum systems. If a conscious observer were not watching an object, then it would have no attributes because there is nothing by which to make the attribution. Since quantum systems don't have minds of their own, some higher, more structurally complex agent is required to provide information for their decoherence. Therefore, reality can be said to be created or constructed by consciousness. As the famous mathematical physicist Eugene Wigner said, it is not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to the consciousness. It will remain remarkable in whatever way our future concepts may develop. The very study of the external world led to the conclusion that the content of consciousness is an ultimate reality. And in fact, according to the CTMU, the content of consciousness is the ultimate reality, and the mind is actually syntactically equivalent to reality in the sense that they share a common structure and processing. And of course, Wigner and von Neumann were well ahead of their time in asserting that the content of consciousness is an ultimate reality, which is then later formalized in the CTMU as the mind equals reality principle and extensively used in the CTMU's interpretation of quantum mechanics. So the problem with quantum mechanical interpretation is that for all presently conceivable experiments, all 7 realities predict exactly the same observable phenomena. Therefore, there's no way to rule one out using the scientific method of hypothesis and experiment. A deeper level of reasoning is now required, one which approaches the question of QM interpretation from a metaphysical level. What are the absolute requirements of any theory of quantum mechanics, and which interpretations best fit these criteria? When applied to quantum mechanics, this reality theoretic analysis is called quantum metamechanics, a field pioneered by Christopher Langan in his paper discussed in this course. Physicists do not know how to use science to find out what kind of world we live in. It seems like quantum mechanics broke science. As Nick Herbert says, physicists' reality crisis is twofold. There are too many of these quantum realities, so we have to get rid of some of them. And all of them, without exception, are preposterous. And obviously, this reality crisis comes because even though the formalisms of QM, of quantum mechanics, are well defined, the reality in which is their codomain is not precisely defined. So when you try to have a meta-interpretive mapping between quantum mechanics and reality, which is needed for self-consistent and self-contained theory of quantum systems, you end up falling short because we don't even know what reality is. So how are we supposed to formulate a theory of quantum mechanics that is real or true? So if we don't want all of our interpretations to be preposterous, then we need to have this self-consistent logical structure of truth that will allow us to formulate a better quantum mechanics. So thank you. God bless. Take care.